Hello, how are you doing? Happy 2019. Yay. I'm a few days late, but this is my first video of the new year, so I wanted to send you my love and many blessings, and I hope that you are happy and refreshed and renewed and ready to take on the new year. So today I wanted to go over the idea of representing a system of linear equations like in algebra and representing it as a matrix. And we'll take our time with this. And this is really like the concept from linear algebra. So working with matrices is more in discrete math, and we will continue building our foundation in algebra on this channel, and we'll use a lot of algebra and move it along into linear algebra, but these are two separate math subjects. Okay, so today I'm going to set up a system of linear equations. We can do a little bit of algebra review here, but we're going to focus on matrices. And I might make this into like a little series. We'll go into row operations and working with the matrix, and we'll talk about row echelon form and reduced row echelon form. But we'll take our time so that we can build the intuition about why we're doing what we're doing and relate it back to our basic algebra concepts. And as usual, in almost every video that I put out, someone will say, I have no idea what's going on. And that's perfectly fine. Just relax and even close your eyes. Or just kind of, you can zone in and out and see what strikes your fancy. In either case, I love this because it's so organized and logical, and it's really fun too. So let me know if you think this is as cool as I do. So let's say we have a system of linear equations. Let's say we have, I wrote out an example for us to work through. X plus 4y equals -2. I just picked numbers and made it work here. So 2x plus 3y equals 1. Okay, so this is a system, because there's two of them, a system of linear equations. One equation, two equations, right? And so we have two variables here, x and y. And so what we're really looking for is a number plus 4 times another number. So the 4 and the y being smushed together means 4 times. And you have to do the order of operations, so 4 times y happens first. So what number plus 4 times another number gives me -2, but at the same time, 2 times that first number plus 3 times that second number gives me 1. So this is like a puzzle or a problem. It's like a game, and we want to figure out what value for x and what value for y satisfies this together, if any. Okay, so we haven't quite covered this in algebra yet, but these are linear equations because when you graph them, you get lines. Okay, and so when you graph this, it's a line, and when you graph this, it's a line. We don't know if it looks like that or that yet, or that, but to represent like like an actual solution, so an x and a y, we're going to look at where the two lines intersect, if at all. So the number of possibilities of solutions will either be just like 1, because those two lines intersect at one point. So it's either going to be one solution, or the two lines might be parallel. Right? So they'll never intersect, which means 0 solutions, or the two lines are basically the same line, one on top of the other, which means infinite solutions. So for two lines and two equations, you'll either have 1, 0, or infinite solutions, infinite number of solutions. Okay, so for now, I can just tell you that this has one solution. So it'll look something like that, roughly. But in algebra, we develop ways to solve this, like by hand, right? We can either use maybe some substitution, where we solve one variable in terms of another variable, and then substitute that expression in, and then solve for one variable, plug that value back in to get the other variable. Or you can do some elimination, where we multiply something on both sides, and then, if we're clever about how we choose them and we add them together, we can eliminate one variable. So we learn a bunch of techniques like that, and we'll go back into this if this is just like, what? But we'll go into this slowly. But assuming we have that foundation in algebra, what we're going to do in linear algebra is represent this entire process using just a matrix, so we can save ourselves time. We can learn methods like Gaussian elimination, which actually is the equivalent of eliminating a variable here. Essentially, it's just more of like an algorithm. But when we represent a system as a matrix, you can sort of do this more methodically. And for this case, we just have like two variables and two equations. But imagine if we're trying to solve this like huge, like 10 by 10, like 10 equations and 10 variables. That would be so tedious to try and solve that all by hand. So let's say we have a computer. That would be quite handy dandy. And so it's going to be helpful to be able to represent your system as just a matrix. So let's focus on how to actually do that. So like I said, in this particular example, we have one solution. So that means we're going to have an x value and one y value, and that will be our solution. Okay? So let's set this system up as a matrix and see what we're really trying to do and what our goal is. So let me let me just box this. This is our system. So what I'm going to do is, what's neat about this is, notice how everything is just lined up. We have x and we have y, right? And so what we're going to do is take the coefficients here and here and just take out the x and y. Because as long as we keep everything nicely lined up, we can just use the matrix to be like a placeholder, right? So to make this into a matrix, we will do, it sounds so fancy, right? Like the matrix. Okay. So really what we're gonna do is take this. Okay. Take the coefficient. So the coefficient of x is 1. You don't see a 1 here, but we know that 1 times any number is itself, because 1 is the multiplicative identity. You might remember that from one of my streams if you've been around, but there's like a secret 1 there. Okay, and then we have 4. And we'll look at this in a second, but for here we have 2x, and then we have 3. Okay, so this thing here, this bracket thing, represents our matrix, or it's like an open bracket. We're going to close it off here, but I'm going to write it like this because notice, as long as we keep everything nicely lined up, right? If we line everything up, we have this is x, this column is y, like coefficients for y, see 4y, 3y, x, and 2x. And then notice that going this way, we have our equation 1 and our equation 2. See that? So it's like nice and pretty. And so then what I'm going to do with the -2 and the 1 here over on this side of the equal sign is I'm going to augment this matrix. So I have 2 by 2, 2 equations, 2 variables. And then I'm going to augment, meaning I'm going to add the other side of the equal sign. So -2 and 1. Then close off the matrix like this. Okay. This line is what augments, you're adding to it. So that line represents the equals, and then this side is this side of the equal sign. See? So now notice that if I have like x minus y, or x minus y, that coefficient would be -1. So we can cover the cases of x plus something and x minus something, right? Or 2x minus 3y. You just put 2 and minus 3, right? So we don't even need like pluses or minuses in between. So this matrix represents this system of linear equations. Does that make sense? Now, remember that in this case we have just x, just y, right? And you can see just reading across means 1x, which is just x, plus 4y equals -2. 2x plus 3y equals 1. So we don't write all this other stuff. That's just there to help us remember. But you can just use this to represent what's happening, right? Now the important thing is to always have everything nicely lined up. So in this case we have 2 variables and 2 equations with and so then it becomes 2 by 2 augmented, and then we have another, so it's 2 by 3. If we have lots and lots of variables, okay, so let's just do like a 3 by 3 case, okay? So let's say we have, I don't know if the numbers are actually going to work out for this, but let's say we have a plus b minus 2c equals 7. And then we have 3a minus 2b. I don't have actual values here, so don't try to solve this. Equals -2. And then let's say we have 2a plus 4c equals -8. Okay. So let's do the same thing that we did with this system of linear equations and make a matrix to represent this. So now already this is going to get a lot more complicated. We have a number plus another number minus 2 times the third number gives me 7. 3 times that first number minus 2 times that second number plus the third number gives me -2. 2 times that first number plus 4 times that third number gives me -8. So you can see how this can be really tedious, and this is a 3 variables and 3 equations situation. So imagine if you have like 10 variables and 10 equations, right? But we can do the same idea. let's make our matrix for this. So let's just take one equation at a time, and just like my point, I'm honing this in. My point is we want to make sure everything lines up nicely. So in your mind, you can picture A, B, C, and then augment, and then the other side of the equal sign. So the coefficient of A is, let's just take this first equation, equation 1, 2, 3, A, B, C, 1, 2, 3. So 1, 1, negative 2, and then augmented 7. And then the next equation is 3A, so we have 3 minus 2 for B, and then C is 1. So I hope you're following that the coefficient is 1 for these, right? And then augmented, and then negative 2. And then here, and this is kind of my point that I'm trying to focus on or emphasize, is we have 2A, but we have no B's here. So we have a 0B and 4C, and then augment, and then negative 8, right? Then we'll close off the matrix. See? So the 0 is because, remember, if for this last one right here, I'm basically adding a 0B because 0 times anything is 0, and anything plus 0 is itself because of the additive identity. If you remember that, the additive identity and the multiplicative identities, kind of mentioned them in a stream, but the idea is just anything plus 0 is itself, like 5 plus 0 is still 5. So essentially I have this hidden 0B here. And so that is what I want to make sure that we're doing when we're lining it up, because this last line here has no B. So it's 2A plus 0B plus 4C equals negative 8. So this is the matrix that represents this. So this saves us some time. We don't have to write, A, B, and C every time. I'm just doing this as like our little annotations here to help us remember what's happening. This is our equation 1, equation 2, and equation 3. So at this point, hopefully, you know how to go from a system of linear equations to a matrix, and vice versa. So you should be able to take now a matrix, and assuming that you know what the variables are actually called, like if it's A, B, C, or x1, x2, x3, that'll probably be given in the context of the problem, or otherwise you can just make up your own as long as you're consistent. But you should be able to go from your matrix and take those as coefficients of each of the variables and set up your system of equations. So you should be able to go both ways now. So now that we know how to take an actual system of equations and write a matrix that represents it, now let's just mention what is our goal then. What does it mean to solve it? What are we trying to do with this matrix? Okay, that's nice, that looks really cool. But our goal, remember, is to solve. So we want to know what x value and what y value, specifically what answer, our answer should be numbers, right? I don't know, negative 2 and 0, if that works. In this case it doesn't work, but we should have an exact value. So what we're going to do is try to take, say, this matrix. Our goal is to go from this 1, 4, negative 2, 2, 3, 1, and somehow get it to look like this. I'm going to write it and I'm going to show you why here in a second. goal is to do stuff to this, which there are rules and operations, which we'll go into in the next video. But we want it to look something like this. What is that? We want 1, 0, 0, 1, and then some number, so I just wrote that number 1, and then another number, number 2. So why? Like, what is happening? Well, remember, if everything is lined up, we have x, y, and equal this, right? So we're going to keep that x, y, and then this line is equals, and then some number, right? And remember, this is an equation 1 and equation 2, right? So essentially what we're doing, which this is not this equation. I'm just saying that in a matrix like this, we have 1 line, 2 lines, right? The second line. So what does this tell me? This is 1 times x. If I were to write this back out, expand this back out into a system of linear equations, I get 1x plus 0y equals whatever that first number is, number 1. 0x plus 1y equals number 2, right? But what is this? Well, 1x is just x, right? So let me see if I can get another color here. I have just x, 0y is just 0, but x plus 0 is x. So I'm just getting x equals some kind of number. 0x is 0, 1y is y, and 0 plus y is y because of the additive identity. So y equals another number, right? So number 2, whatever that number is. Isn't that cool? So essentially, if I can get this matrix that represents the original system of linear equations and get it into this form, I've solved it, because now I know x is whatever this number is, and y is whatever this number is. Does that make sense? So, because when I first wrote the system of linear equations, I said that this was our goal. X equals what and y equals what. But what I didn't really write here is this. If I want to keep everything lined up like this, it's basically 1x plus 0y equals what, and 0x plus 1y equals what. And so once we learned how to do this matrix stuff, we can just take the coefficients 1, 0, 0, 1, what, right? What. So that's kind of cool, right? So now we're going to try to get from point A to point B. And so there's a special name for this, like 1001 stuff. And so that's like the echelon form and reduced row echelon form and all that. We'll go into that some more. But for now, I hope that it makes more sense why we're going from point A, which is the matrix that represents our system of equations, to point B. This is our goal, to get something that looks like this. And in the 3x3 case, we're going to try and go. So we're going to talk about the rules for how to get there, how to work with this matrix. But in this case, we're going to try and do the same thing. We're going to try and get to 1, 0, 0, and it really does depend on how many solutions you have, but I'm just talking about the most basic case of just 1, so it might not be like this in this case, but essentially you want it to be like a staircase going down with your ones. We'll talk about this later. Okay. But you can see that already. I mean, ideally, if it just looks nice like this. I mean, if it looks nice and pretty like this, it'd be nice because you'll see that this means C, because it's 0a plus 0b plus 1c, so that's just C equals this number, B equals this number, and A equals this number. So, I mean, that's nice if we have it like that. And sometimes we won't get it quite so directly, but this would represent the solution for this. So we'll go into this some more. I haven't worked out this exact example. I don't even think the numbers are that nice. I'm not sure, but I hope that gives you a general idea of what we're trying to do and kind of set up a general direction why we're trying to go from here to here. So I think we're going to stick with the 2 by 2 case first, which then gets augmented to 2 by 3, and then we'll kind of continue building our intuition for what we're going to do with like the rows and the terms and what this means. But for now, I hope that it's clear how to set up the matrix and just generally what it means to solve it. Okay, then I will see you soon. Don't hesitate to let me know if you have any questions, or if you're learning math, even if it's like a completely unrelated topic. Stick around, subscribe if you want to see more math on this channel for 2019. Thank you for joining me, and I will have a sleepy math video soon as well to help you fall asleep and relax some more. Okay, I'll see you around. Bye.